let's spend a little more time calculating slope using the slope formula when we're given 2 points on a line. The first ordered pair of the x and y, the x1, y1, is my first point on this line, and the second ordered pair is my second point, my x2, y2. I go ahead and use my formula, my y2 minus y1 over my x2 minus x1. I simplify, and I look at this and I say this can be simplified a little further. It's a 3-to-1 ratio. It's telling me it's a positive slope, positive number 3, up 3, and over 1. We'll do some graphing next class. So now I can even simplify that a little further and just say that my slope is a positive 3, which means it's going to go uphill, as we mentioned last time. Now on my second problem, again, I'm going to substitute in all those values. I have 10 minus 10, my change in y, over my change in x. It simplifies to 0 over 5. This slope is 0. Why? Because there's no change in the rise. It is a straight line, and this is a horizontal line. One of the ways that I remember that the horizontal line has a 0 slope, because horizontal and 0 both have z's. So 0, horizontal. Let's take a look at 1 or 2 more examples. In my next problem, I'm going to look at the following points. I'm going to have okay, so again, let's find the difference. I have 4 minus a negative 3 over 6 minus 6. You know the rules of subtraction tell you to keep and add the opposite. So this gives me 7 over 0. We can never divide by 0, so the slope is undefined. And again, this would be a vertical line. A vertical line is undefined. Okay, so these are 2 unique situations here that we did not discuss the last time, but I wanted to make you aware of that there were not just 2 types of lines, but there were 4. So looking at what those 4 lines represent, and we had this on our last slide, I believe, where we had our incline or our positive slope. It rises from left to right. So perhaps that slope might be m is equal to 4. I could have a line that descends or falls from left to right. This is my negative slope. And the negative slope could be something like m is equal to negative 2. Then I have my horizontal line. My horizontal line says this is a 0 slope. So m is equal to 0, and you need to write that. And then I might have my vertical line. My vertical line, my slope, m is undefined. And that could be something like 2 over 0. So I'm giving you some possibilities as to what the slope value might be and how it might also be written as a number value as well. Uphill, positive, downhill, negative. Horizontal line, 0 slope. Vertical line is undefined. Okay, those are the ones you really want to focus on. So looking at this again, we'll practice a few more. Let's just take a look at maybe 1 more example or 2 today. But as we're doing these, we want to be able to see that these are some of the statements that I wrote perhaps in a different way. We're classifying the lines by slope. If the slope value is greater than 0, it's that positive slope. A line with a negative slope where m is less than 0, so I could have something in this first one, first off, as m is equal to 4x minus 1. Remember, m is my slope right there. That's positive. It's greater than 0, so it's a positive slope. My second one could have an example like y is equal to a negative 3x plus 2. Here's my slope. It's negative in number, negative in direction. My slope is 0, and that becomes y as a constant, so I might have y is equal to 3. And then we have my undefined, where we'll have x is equal to maybe negative 2. So we'll talk a little bit more about what those equations are, but this was just an important bit of information here that says that we can classify our equations by looking at the direction of the line on a graph, or even looking at the equation and seeing what that value is that m is represented by. I'm going to stop at this point because this is something for you to just sort of take in a little bit and understand. We'll do more of it next class since today is a short class.